this video, we are exploring implementing Node.jS GraphQL API, and we would like to see the differences between the GraphQL and REST API for the Node.js developer. Refer to the diagram that you can see on the screen, the user providing a GraphQL request. So the query consists of a book information and the book rating, which is formulated in some special notation called GraphQL. Once the query has been received by the GraphQL runtime, it starts looking after to formulate and process the query, as well as finding the related dataset or databases that can answer this request. Once the query is being processed, the response will be ready and the user will receive that information. Looking into the most popular API architectures around the world, we can see that REST is having a good chunk of the market compared to the other form of API architectures like SOAP, like gRPC, and many others. But unlike regular SOAP or REST API, GraphQL let the client specify exactly what data is needed and make it easier to aggregate data from multiple sources. In order to understand the GraphQL, so are we gonna go to the official website of the GraphQL and take a look? GraphQL has started late 2015, and as you can see, it's normally a notation that helps user to formulate different queries, which is very familiar with the JavaScript developer notations. GraphQL mainly is using a query languages, and it's a pattern, not it's a technology. Looking into the GraphQL official website, so that brings us into this website, which is telling us here is what we are looking for as a way to describe our data, as a way to ask what we are looking for, and as a way that we can predict the result. It's a query language for our API as per official website. This website provides us tons of tutorials, and for those who are interested, they can take a look quickly. You can see that over here in this kind of demonstration, user is looking into the hero names like name and height and etc. And the response will be provided in the same JSON notation. And that's maybe one of the integral points of using GraphQL. Moving forward, GraphQL is a query language and server-side runtime for application programming interface that prioritize giving client exactly the data they request and, of course, no more. GraphQL is a query language for our API, sending a GraphQL query to the API and get exactly what we need. Nothing more, nothing less. GraphQL queries always return predictable result, and as we saw on the official website, we know how this query now look like. Apps using GraphQL are fast, stable because they control the data they get, not the server. There are three areas in the GraphQL which we call it GraphQL main building block. Number one is the schema, which defines a set of types, describe possible data you can query on your API. Then we need to provide the operation that we are looking for. If you look at the notation, so when compare it with the REST API, in the REST API we have app.get, app.post, and etc., which defines the operation that we are looking for. But over here, we do have query, we do have mutation, we do have a subscription. Query refers to a kind of getting the information or reading the data. Mutation refers to any modification on the server-side data, and subscription allows for notification of changes to the data in real time. Another and most important components in the GraphQL building block is resolver, which are basically functions that help us to process the data, process the query, and provide what we are looking for out of that query. There are two main components for running GraphQL API. The first one is the GraphQL server, which serves on the API side. And we can use any kind of middleware like Express.js in our example, or we can go with the GraphQL client, which connects our endpoint and can visualize what we are looking for with that GraphQL. We saw a name like GraphiQL and Apollo client, which are mainly two famous GraphQL clients. In order to set up our very first Node.js application that interacts with the GraphQL, the step one, we are looking for a couple of different important middlewares around us. First one is the GraphQL, which is the JavaScript reference implementation for GraphQL. And we have two more, GraphQL HTTP, and number three is the RURL. We are going to understand, how to utilize this in a simple example in a few minutes. This video consists of, three or four different examples that we are going to explore quickly, and those, examples will be given, in the comment section later. The step two in our GraphQL Node.js application is going to be create an executable GraphQL schema. You can create a data object with the value your database would have, and then based upon that, you need to get started and formulate, how your query look like and how user is expected to form that query. And that is exactly what we are looking for. We do have our schema over here. So, and then we do have our query. So the schema over here is very interesting. So we do have a schema, just a simple one. And our query is simply, having one single property, which is the hello. And we're going to see it in the example in a few seconds. Of course, we need a resolver function, and the resolver function can are simply a collection of functions that generate responses for the GraphQL server. Resolver normally is a function and return data for specific fields in the schema. So if in our example, if you go back, all right, so we do have one particular field over here, and then that is satisfying the resolver option. You can see in this particular example, our schema and the queries there, and finally the resolver at the very end is a simple function that returns hello world. Our very first example in this series, right, so it's going to be example number one. In the example number one, which is basically you can find it on GraphQL website, we do create a very simple schema. To construct the schema, we do just need to use the build schema command, and build schema is one of the methods that we are using in the GraphQL. Then we need to provide a root value, which is our resolver function. And the resolver is just, we do have a name of hello, and then that returns hello world over here for us. And the last but not least, we are going to run the GraphQL hello, right? So, and print out the response in the output. You can see that over here, we do have the GraphQL and then the schema, and the source is hello, which is passed by, is our input. And then we are using the promise-based approach to just simply return the value. If we do run this query quickly here, which is the number one here, we're going to see here in the output the hello. Right? You can see that the output is being generated over here as we expect. What happened over here, it's just a simple schema with one field. We pass hello to that field, and here is what we are receiving at the end. The second example that I wanted to show you, right, so is helping us with a little more, right? In the second example, what do we have? So we do have a server which is listening to the port 4000. That's good. And then we do have our new routes, which is the /GraphQL, and that route basically is utilizing the schema that we have designed. And what we are expecting to happen is to calling this hello and then getting the output as we expect. So this example is another version of the example one, we do still have the same schema, same query, same resolver, but since we are using Express, of course, we do have our routes, and then with that routes, which is a slash GraphQL, we are expecting to receive the outcome of this GraphQL application. So let's see how that works. So we're gonna go and then run the GraphQL number two example. The server is listening to the port 4000, and if I open up, my browser, it's gonna tell me you miss the query, right? Um, the reason that I'm getting this error because first of all, I need to formulate and then run the GraphQL query in very specific notations. If I use my Thunder client, I can go to GraphQL, you look at the get method, and then I can pass the query parameter like query, and then pass the value like hello, right? And then if I do that, right, so I'm gonna get hello world in the output. So if I try the same formulation here into the browser, and then paste it up here, I'm gonna get hello world over here. So you can see that my data right now is the hello. Hello is our resolver. And then when we call that function, it returns hello world. So for now, what we have over here, we just create a very simple schema, very simple resolver, and very simple route so far in the application. Moving back here, right? So it's gonna tell us, right? So that in this example, we are using the GraphQL HTTP, if you notice. Going back here, so I'm using the GraphQL HTTP, which is our new friend, right? So in working with the GraphQL package is always, the masterpiece, and GraphQL HTTP is a kind of replacement of something that we had before. It was calling Express GraphQL, right? So that is almost deprecated. GraphQL, Express is deprecated, and instead of that, so we are using GraphQL HTTP. And that helps us to work with the regular Express application, which is listening to the server, to the port number and etc. If you remember earlier, so we mentioned that in order to run a GraphQL application, we need a GraphQL server. And our server right now is the Express server because we still need to have a server to listen to a particular port number. And when user reach out to a particular route, then run the GraphQL query, which is exactly what we are doing. Our application now consists of GraphQL, GraphQL HTTP, and without this last one, which is Ruru, and we define the schema, we define the query, and we define the resolver as well. And finally, we were able to combine the tree, right? And this diagram clearly identify that, okay, yeah, so here is our schema, and here is our root, which is potentially our resolver function that we have here named hello. So far, so good. We wanted to add another thing, which is called GraphQL. GraphQL is the in-browser tools for writing, validating, and testing GraphQL queries. Ruru and Ruru HTML are used to serve GraphQL UI. And the way that they are going to work is that once we include that package into our program, if user get access to a particular route, it generates a kind of interface that user can type in the query and then see how it works. I'm going to show you quickly in a simple example, which is example number 3. In the example number 3, we do have our same setup, like Express is there, GraphQL is there, and then we are using couple of different packages, including this Ruru server. What we are doing here is that we do create a root query type, which is an object of the GraphQL object type. we do create, okay, here is the name is query, fields are hello, and then the resolver function is right here. You see, we have a little more structure, right? So compared to the first simple example. And then we do keep this simple definition of schema plus resolver. In other words, how this is going to look like, we do use a GraphQL object type. We create an object like query. It has a couple of fields, and here is the resolver. And the resolver simply return hello world. Our schema is using the GraphQL schema item. Again, GraphQL schema, GraphQL object type are all different products or different methods out of the GraphQL package. And then we do create our handler based on the create the schema which listen to the GraphQL options. And then finally we are using the Ruru HTML in order to provide us that interface. So let's get into running this, because this example realistically giving us a better insight about what's going on. So as soon as I start running it again, so I can see the same atmosphere, right? So over here, so the application is working as before. If I'm running it in this way, like a traditional way of, okay, passing the query here, here is my query, here is the value, here is the hello. So we done that before. But we wanted to take a look on this one. So the GraphiQL interface, which is listening to the port 4000 currently. And we wanted to see how that is going to work. So you can see that if I go to the root and then that automatically, render the interface for me in order to run and then formulate my own query here. So let's open this guy here. Here we go. So you can see that this is the kind of GraphQL in the browser tool for writing, validating, and testing the queries. It is telling me how I can formulate, the query over here, and what should I do in every single step. So in order to make that happen, I'm gonna type here query, right? So and then open this up, and then I'm gonna type here hello, right? So you can see that as soon as I type, it using the IntelliSense is gonna tell me how it is going to be look like. I'm gonna run this, and there we go. So I'm gonna get the hello, right? What you are, witnessing right now on the left-hand side and right-hand side, I can formulate the query over here. So you can see that the hashes are kind of, comment section. It's a little guide, right? So, and then it's telling me, how I can formulate, my queries here. Since the query type that I was using here was named query, right? So I'm going to use exactly the same thing, and the field over here is hello, and the resolver is right there. So that's everything that I need. So again, if we look closely to the application that we created right now, here is the part that we declare the schema. Here is the part that we instantiate our GraphQL uh, query based on the defined schema over here. Here is how we activate, right? So the server to run on the slash GraphQL and then create the handler, right? So it means that, so it's set up the GraphQL endpoint using the GraphQl-http. And then here is the masterpiece for us at the moment. We are using the GraphQL, which we just saw it, how it works, right? So in the demonstration right here. And if you do a mistake here, like instead of this say hello one, so of course you're gonna get, the proper error messages right there. All right, so far so good. So far we were able to get our hands, on this concept. But I wanted to, before I go with the GraphQL benefits, I wanted to go with a kind of realistic, maybe example. Um, Let me just stop this here, and then I'm gonna run the example number 4, and at the same time I'm gonna explain, what is this example number 4 all about. If you look at the example number 4, We do use the same set, like, okay, again, so Express, HTTP, GraphQL HTTP, and Ruru. So these are the three items that we are using, as well as, of course, the GraphQL is always there. Um, the very first step, right? So in this kind of program, I do have my data, right? So you can see that my data is there, consists of authors and books, and noticing that every book has one of these authors. Like you can see that author ID is there, kind of primary key, foreign key concept. You can see here between authors and books, and then like the way that we did it in the previous one, you can see here that I'm started creating GraphQL object type. My first object is book. The book has ID, name, author, and author, is related to, the other kind of data set. So author ID working like a foreign key to some extent, and the resolver is finding, okay, whose author is for this book, right? You can see that conditional statement in the resolve part. And then we do have the author, right? So and this is for a book, right? So you're gonna see the book, right? So based on different author, again, ID, name, and their book. And then we have another one which is query, and the query simply helping us like a get method, right? So it's helping us to extract all the books. If it is single book, of course single book is easy, you can just pass the ID and then you're going to see the book. Or if you are looking for books, so then you are going to display all the books, right? So and then you're going to see them. We do have authors, again, same idea, list of all the authors, or you can get access to individual author. You see, the query, I mean, the GraphQL implementation is thinking ahead of time about the queries that you are going to, answer, right? And then the resolver is always a masterpiece in your coding environment. You see, all these queries has the resolver, and the resolver simply generates, the output. Um, we do have something called mutation, and the mutation, if you remember in the maybe at the beginning of the presentation, mutation is for insert, update, delete, something like that. Like you can add a book, right? So if you want to, and then since I'm using array, probably adding a book is just a matter of pushing, right? So a new instance to the list, something like that, but needs to be mindful that okay, we're gonna generate a new ID for the book, right? And then keep the association between the book and author if the author is writing that book, right? So we have to make that happen. And this is of course only the add operation. We can do the delete, we can do the update in a similar way. And once we have all the queries in place, we just simply say that, okay, here is our schema, consists of query, consists of mutation. And we don't have the subscription at the moment, but this is the best that we could do with the simple example in this video. And then the last piece is almost pretty much similar to the other two examples that I show you, right? You see, the structure is always remain the same because these are like a building block. Maybe the only thing that we keep changing is going to be the query itself, right? Okay, so let's take a look on how it is going to look like, right? So in the outputs, okay? So I'm gonna quickly run this, and there we go. Okay, so I have created, my queries ready. So I'm gonna demonstrate, how the query look like. You remember we had something like authors, right? So if I run this, I'm gonna see all the authors over here, right? So I can see all the authors for that particular book. I can change authors, right? So to something like books, right? So, and again, run it, and I'm going to see all the books, right? So based on my data. So I'm not too sure whether you are a fan of, Harry Potter, but you can see lots of Harry Potter books. Right? So over here. Books and authors is just for all everything, but you can see that you can manage. Let me just comments this out, control dash, and then comment this, right? So this is going to be, for particular book, right? So like if you are looking for the book number 9, right? So of course, book number 9 does not exist. So how about book number, let's say 7, right? So do we have book number 7? Yes, we do, right? So here is the book number 7. How about book number 6? Do we have book number 6? Yes, we do, right? And if we look at the code, right, so just examine whether we are catching the correct book or not, right? So you can see that book 7, right? So 6, right? So it's correct, right? So we were able to extract proper book. And then again, what we are doing here to just understand what's going on, when you are looking for book, you look after, a particular ID, right? Once you have that ID, it's going to show you, that particular book information. So we have book and author over here. And in the query section, we do create a couple of different things. So if you are searching for a single book, this is what you're going to do. If you are searching for all the books, this is what you're going to do. So the difference maybe here, as you can identify, is having, the arguments here, right? So what we are doing, in this diagram, so let me just grab this and then bring it here. Okay. So um, the notation that we are using here is exactly based upon, the um, query that we formulated already here, right? So like if I'm looking for books, right? So here is what I'm doing here. So I'm looking for ID and name over here, and then in the result function, it's going to return every single books, right? So in the repository. If I'm looking for the book with the ID, so the ID that I'm passing here is going to be ID number 6, right? And then it does the resolve. It's going to find that book. You see the resolver function now have a better kind of approach, looking into the item in the array and then bring it up. And then similarly, so we can do something like a mutation, right? So like in the mutation, what I can do, so I can add maybe a book here, right? So and pass it in, so you can see that the book is being added using the ID number 9. So what I'm doing, I'm gonna say that so a name is this, author is this, right? So it's going to add that book for me, right? And then I can also, add, an author here, right? So just in case, right? So, oh, sorry. So it's going to help me to run that book as well, right? So with the ID as well, and this is how it works. So if I look at, let me just comment this out again. If I go and check the book again one more time, right? So it is going to tell me here are the people who are writing the book, and here are like this book is by author number 1, this book is by author number 1, some of them is by author number 2, and this book is designed by author number 3, which is the last book that we entered here. You can see that the query is a kind of join query, like book and author based on the matching ID, right? How it works. So I hope this demonstration, could help you to understand, the main building block of GraphQL. So GraphQL has tons of benefits. Like, of course, we can have a strongly, typed schema, can be shared with the client and server, can validate requests at the built-in, have an autocomplete query and mutation. You saw the queries are very interactive, and then you can use that GraphQL environment. There is no underfetching or overfetching of data in REST API. If you think about it, if I wanted to get the book data, so I extract every book, right? But now I have the opportunity to filter out, right? So and then extract that piece that I need exactly. There's no, getting more data than what we are looking for or what we needed. Um, But when we do the quick comparison between REST and GraphQL over here in a short things, data fetching. REST, we have a multiple endpoint, may cause sometimes the over or under fetching. In GraphQL, we have one endpoint, slash GraphQL, that's it. And um, just we need to spend time, right, on formulating the queries. Network efficiency, right? So potential multiple round trip to the gathering all data for the rest. GraphQL could be easier, but you need to invest that time on developing response size. Yeah, so fixed resource structure may return unused fields sometimes in the rest. We have a better efficiency, but we do see some complexity on the server implementation, the caching part, the performance tuning, um, maturity of tools, because GraphQL tools are keep changing. Even the Ruru things that I just mentioned over here was kind of, not the final version, so you need to be aware of that as well, and other aspects. I hope this video helped you to understand the workflow of implementing Node.js GraphQL API, and thank you for listening to this video.